Hi. Okay, we're going to start with the review of the Chapter 7 quiz to make sure that we're all kind of on the same page and we understand what's going on for your upcoming exam. Most of you did pretty well on the first question, which was balancing equations, but let's just review it a little bit right here. I also want to point out there are suggestions on a slide in Chapter 7 of how you should go about doing these. They don't always work. And sometimes you have to balance equations based off of trial and error until you get it balanced. If you're working with chemical reactions that have large numbers of atoms, then I highly recommend that you draw the table that we did when we're doing a couple examples in class. Okay, so the first one I think almost everybody got right. Anytime you're working with two singular reactants forming a compound, so a synthesis reaction, start with trying to fix your compound and then go back to the individual reactants. So if we look at the compound here, bromine, we have 3 bromines and aluminum bromide. So we're working with a diatomic molecule on the reactant side. So what we need to do is try to make the number of bromines on the reactant product side an even number, because that's the only thing that we can adjust in when we're on the reactant side. So I'm going to start by adding a 2 here. So that's going to give us 6 bromines. We have a diatomic molecule of bromine on the reactant side, so I need to put a 3 in front of here in order to get 6 bromines on the reactant side. When we added the 2 coefficient in front of aluminum bromide, we also changed the number of aluminum. So now we have 2 aluminum on the product side, so we need to make sure we have 2 aluminum on the reactant side. Okay, moving on to the next one. I think I'm going to start with adjusting phosphate, because that's when I can clearly tell that it's different. Again, this is just how I'm doing it. You might have a completely different method of how you're going to go in and balance it. So if I looked on the reactant side, I have 1 phosphate. If I look on the product side, I have 2 phosphates. So I'm going to make a 2 phosphate on the reactant side. When I make the 2 phosphate, sodium phosphate on the reactant side, my phosphates are now equal, but I've changed the number of sodiums. So I have 6 sodium on the reactant side, because this is a 3. If we have 2 Na3s, that means we have 6 total sodiums. So we need to make sure that we have 6 total sodiums on the product side. So I'm going to place a 6 right here. So now my sodiums are balanced, but I've also changed the number of acetates on the product side because I placed the 6 in front of sodium acetate. So I have 6 acetates on the product side, so let's make sure we have 6 acetates on the reactant side. So we have acetate, we have 2 acetates in this particular molecule. So in order to get 6, I need to put a 3 as a coefficient. 3 times 2 is 6. When I place the 3 as a coefficient, I have changed the number of zinc on the reactant side. So I have 3 zinc. So looking at the product side, I have 3 zinc. So we don't need to do anything there. Make sure, now that we have everything balanced and all of our atoms on either side of the equation are correct, that you do not leave this space blank, even though you wouldn't typically write a 1. For your exam, you need to make sure you fill in this blank and write a 1 as a coefficient. It's written on this quiz and it's written on your exam as well, that you should not be leaving any blank empty. Okay, moving on to the last one, it gets a little trickier because we're dealing with so many compounds or molecules that contain oxygen. So they always recommend that you deal with compounds containing oxygen last. So I'm going to start with, let's see, I'm going to place a 2 here. Let's start working with the carbons and see what happens. So if I put a 2 there, that means I have 6 carbons total, because I have 3 carbons per molecule. So now I have 6. So now I need to make sure I have 6 carbons on the reactant side. So I place a 6 in front of carbon dioxide. So I have 6 carbons on the reactant and product side, but I've changed the number of oxygens. Now I have 12 oxygens here. We also, by placing a 2 right here, we have changed the number of hydrogens. We have 12 hydrogens on the reactant side. let's make sure we get 12 hydrogens on the product side. So I need to place a 6 right here. 6 times 2 is 12, so we have 12 hydrogens on this side. So our hydrogens and our carbons are balanced as is. The only thing we still need to balance is the number of oxygens. So let's start with our reactants product side. We have 12 oxygens from carbon dioxide, and over here with 6 water molecules, that's going to represent 6 oxygens here. So collectively, we have 18 oxygens on the product side. So we need to have 18 oxygens on the reactant side. So I'm going to place a 9 in front of our diatomic oxygen over here, and that will give us 18. Okay, the next question is probably the easiest question, but I realize a lot of you didn't know this. So make sure you know this because you're going to see diatomic molecules on your exam, and you're also going to need to be able to write these when you're doing chemical reactions. And there was actually an example of this on your quiz that we're going to work through. Okay, so we have 7 diatomic molecules, and you just needed to name 5 of them. So let's review on the periodic table. And it's sideways because this is the one you were given on your quiz. So make sure you kind of understand how to do this. So there's 7 diatomic molecules, and it makes a 7 on the periodic table. So this is the 7 that it makes. And then we're also going to include hydrogen because hydrogen is a diatomic molecule. So the molecules that are outlined in blue right now, those are your diatomic molecules. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So 7 diatomic molecules makes a 7 on the periodic table, and then we also have to include hydrogen. So if you listed any 5 of those, you got that completely correct. If you listed 2 of them out of the 7, then you got 2 points, and that's how that worked. Okay, the third question was going into chemical reactions, asking you to determine the reaction type and then complete and balance the chemical reaction. Okay, so let's start with the first one. The first one is saying aqueous ammonium chromate reacts with aqueous calcium chloride. So let's start by writing our compounds. So we have ammonium. This is why it's so important that you learned your polyatomic ions way back when. I think it was chapter 4. Okay, so ammonium is NH4 and chromate is CrO4. Aqueous reacts with aqueous calcium chloride. Okay, here's another error that a couple of you made. Calcium chloride is just a calcium ion bound to a chloride ion. Okay, a lot of you wrote like chloride or chlorate or included an oxygen for some reason. Calcium chloride is just calcium and chloride. Okay, so we need a calcium and a chlorine atom, and it's aqueous. Before you go on to write your products, make sure your compounds are written correctly. How do you know if your compounds are written correctly? You have to look at the charges. So let's do that. An ammonium ion has a +1 charge, which you also need to memorize way back when, and chromate has a -2 charge. So all compounds are going to be in a neutral state. So we have to make sure we have the correct number of ions so the compound is neutral. So chromate's -2, which means we need 2 positive charges associated with it. So we don't just need 1 ammonium, we actually need 2. So now we have 2 positive charges to counterbalance our -2 charge on our chromate. The next thing, let's look at calcium chloride. Calcium has a +2 charge. Chlorine has a -1 charge, so this is not correctly written compound. We need to balance out our +2 calcium charge with 2 chlorine atoms that are both -1 so that we have two negative charges to balance out the positive 2 charge on calcium. Okay, so now our compounds are written correctly. Let's figure out what our products are. So this is a double replacement reaction. This is another place where a couple of you went wrong. When you're doing a double displacement reaction or replacement reaction, you can't just randomly choose what pairs up. Every compound in a product has to be composed of a cation and an anion. A lot of you wrote 2 anions bound together and 2 cations bound together. Remember, compounds are always going to be represented as a neutral compound. So your charges have to balance out. You can't pair 2 cations and 2 anions together. So what you need to do is either swap the 2 cations between the 2 compounds as the reactants, or swap the 2 anions, okay? It doesn't matter which one you're gonna do, because when you make the swap either way, you end up with the same compounds. So I'm gonna say let's swap our cations because we always write our cations first. So what we're gonna do is we're gonna swap our ammonium and our calcium in these compounds. So let's start with writing our ammonium ion, and we're going to bind it to chlorine. Why are we binding it to chlorine? Because that's the anion in the other compound. You have to have a cation and an anion bound together, and you don't want the same cation bound to the same anion, so our only option is ammonium chloride. Okay, the next one, we're going to take our calcium and we are going to pair it with the anion in the other compound, which would be chromate. Okay, we have our compounds. We still have to check to make sure our compounds are written correctly. So let's check for charges. So we have ammonium, which has a positive 1 charge, and a chlorine atom, which has a negative 1 charge. We have a calcium ion that has a plus 2 charge, and a chromate ion that has a negative 2 charge. So our compounds are balanced as is. Their charges are balanced as is, so we don't need to do anything to this. They are written correctly. The next thing we need to do is to go in and balance the equation, okay? Don't forget to balance the equation. So let's check for what we have. If we're looking at ammonium on the reactant side, we have 2. Let's look on the product side. We only have 1. So we need to change that, and the only thing that we can change after we wrote our compounds is the coefficient. So we added 2 in front of the ammonium, and now our ammoniums are balanced. But we've changed the number of chlorines in this compound as well. We have 2 chlorines. So let's look at chlorine on the reactant side. We have 2, so that's great. Let's move on to check our chromates. We have 1 chromate on the reactant side. We have 1 chromate on the product side, so those are fine. Let's check our calcium. We have 1 calcium on the product side, and we have 1 calcium on the reactant side, so those are fine. So the only thing we needed to do in order to balance this equation is to add the 2 coefficient in front of ammonium chloride. The next thing that you need to do is determine what state of matter our products are in. And because we are working with a double replacement reaction, the only way we can determine what state the products are in is by looking at the solubility rules, okay? So let's go to the solubility rules, which you are given. Okay, ammonium chloride. So ammonium chloride, let's look here. All halide ions, we have a chlorine in our ammonium chloride, are going to be soluble. Let's see what our exceptions are. We do not have any silver, mercury, or lead bound to our chlorine atom, so I think we are good to go. We are going to be soluble, which means that that's going to be an aqueous product. So now we can write in AQ. Okay, calcium chromate. Let's go in and look at calcium chromate. Here we go. Here's a chromate ion. Chromate ion says, oh, it turned it into a square. Oh, well, that is going to be insoluble. So if it's insoluble, that means it's going to form a solid because it's not soluble. So our chromate is solid. Okay, so now we have completed the reaction and everything that has asked for you. Because we are working with a reaction that's going complete through a double replacement, you might want to go ahead and go in and maybe work on a complete ionic reaction and a net ionic reaction if you want to incorporate some more information like from chapter 8. Okay, so that's the answer that you should have gotten. Again, the errors that I saw here is 1, which means that you really need to study, is that people don't know what the polyatomic ions are, okay? Some people who knew what the polyatomic ions are didn't understand what the charges are, so they forgot the 2 on ammonium because they didn't realize that it was +1 while chromate was -2. So make sure you know your polyatomic ions, what charges they represent, write your compounds correctly, write your products, make sure your product compounds are balanced as far as charges go, make sure your entire chemical reaction is balanced, and when you're working with double replacement, make sure you're going in and looking at the solubility rules to determine the state of your matter. Okay, next one is aqueous aluminum nitrate reacts with solid barium. So let's go in and do that. We have aluminum and then nitrate is NO3 and it's aqueous plus solid barium. Okay, so let's make sure our compound is written correctly. So aluminum has a +3 charge and nitrate has a -1 charge. So we have to make sure these charges cancel out. So the only way that we can cancel out these charges in this compound is making sure we have 3 nitrate so that we have 3 negative charges total to counterbalance the +3 charge on aluminum. Barium's a solid, so we're good there. So let's go in and see what our products are. This is a single replacement. So for a single replacement, we have to go in and look at the activity series. So let's go look at the activity series. Here's our activity series. What we're working with is our metals. So in our original compound was aluminum nitrate. So here's aluminum. Our solid was barium. Barium is more reactive than aluminum. Because barium is more reactive than aluminum, this reaction is going to occur. So the individual solid metal has to be more reactive than the one that's bound to the nonmetal in order for it to occur. If it's not more reactive, then the reaction is not going to occur. So a lot of you kind of got confused there. If it's more reactive on the activity series, that means the reaction is going to occur and it's going to react. Okay, so this reaction is going to occur, which means that we are going to have barium that's bound to nitrate, and we're going to end up with aluminum by itself as a solid, and then this is going to be aqueous. Okay, so we know what products we have. Let's make sure the compound that we wrote as a product has its charges that are canceling each other out. So barium has a +2 charge, looking at the periodic table. Nitrate has a -1 charge. So we need 2 nitrates in order to make sure we have 2 negative charges to balance out the +2 on barium. So our compound is written correctly. Our next step is to go in and make sure our chemical equation is balanced. So let's do that. So we have 1 aluminum on the reactant side. We have 1 aluminum on the product side. So we're good there. We have 3 nitrate on the reactant side. We have 2 nitrate on the product side. So we need to change that. So we can't change the nitrate, but in intervals of 2. So our best thing that we can do is to put a 3 here. So we're going to have 6 nitrate, because if we were to true there, we would have 4 nitrate, but over here in this compound, they're in intervals of 3. So that's not going to work. So we need something that both 3 and 2 can go in, which is 6. So I put a 3 as a coefficient in front of barium nitrate. So now we have 3 times 2, we have 6 nitrate. Going back to our reactant side, we only had 3 nitrate, so I need to put a 2 in front of this compound. 2 times 3 is 6, so we have 6 nitrate on both sides. So we changed 2 things when we wrote those coefficients. Let's go back to our product side. For our barium nitrate, we made 3 barium. So let's make sure we have 3 barium on our reactant side. For our aluminum nitrate, when we put the 2 as a coefficient, that made sure we had 2 aluminum on the reactant side. So we need to make sure we put a 2 in front of the aluminum on the product side. And now our equation is balanced. Okay, so error is made on this again. The same ones on part A, where you weren't making sure that your compounds were written correctly as far as charges canceling each other out and making a neutral compound. Making sure you balance the entire equation, and making sure you check the activity series. If something is more reactive, if the solid metal is more reactive than the one in the compound, the reaction is going to occur. If the solid metal is less reactive than the one that's bound in the compound, then nothing's going to happen because that solid metal is less reactive. Okay, moving on to the last one. A lot of you had the right idea here, but you forgot something very important. And the very important thing I'm about to tell you. Okay, so solid lithium, lithium's just Li, and we'll write it solid, reacts with solid iodine. Iodine is one of your diatomic molecules, meaning that it's only found in the diatomic form. So you have to write iodine as a diatomic molecule. You do not have a choice because that's how it's found. We would never find an individual iodine by itself. So another important reason that you know what your diatomic molecules are. So we have our diatomic iodine right there as a solid per what the reaction says. And this is a combination reaction, so we're just going to combine them to lithium iodide. Okay, let's check our charges, make sure our compound's written correctly. If we look at a periodic table, lithium has a +1 and iodine has a -1. So this compound is perfect as is. We don't have to change anything. However, we can already kind of tell that our atoms are not balanced, so we need to make sure we balance the chemical equation. We have 2 iodines on the reactant side, and we have 1 on the product side, so we need to add a 2 as a coefficient there. When we add a 2 as a coefficient there, we've also changed the number of lithium. So we have 2 lithiums on the product side, so let's go in and add a 2 in front of lithium on the reactant side. So now everything is balanced. Okay, and like I just did, so let me not forget, make sure when you're done with your upcoming exam that you have written all the states of matter after each one of either the molecules or the compounds in your chemical reaction. Like I just forgot to write one. So that's something that you could easily lose partial points off of. So make sure you double check that. Make sure everything is balanced. Make sure you wrote the compounds correctly so that the charges of the 2 ions cancel each other out. Make sure you're checking the activity series. If we're talking about a single replacement, make sure you are checking the solubility rules if we're talking about the products for a double replacement. In this case, all 3 of these examples on your quiz had reactions occur. So make sure you understand when we don't have a reaction occur. So for example, for a double replacement, if both products are soluble and they're aqueous, no reaction will occur. And if we're talking about a single replacement and you're checking the activity series, No reaction will occur if the solid that the compound is reacting with is less reactive than the metal that's bound in the compound to begin with. Okay, I hope this helped. Again, if you missed anything, it was probably something small because most of you had the right idea, you just forgot something. So this is why I wanted to make this video, to kind of point out the things you may